Hi, welcome back to our course, Introduction to Machine Learning in Julia. We are continuing to learn some basics of Julia, and right after that, we'll be entering into data science, machine learning, and deep learning. So, in the last couple of lectures, we looked at some basic syntax of Julia. In this lecture, we'll be learning something called as Pluto Notebooks. It is similar to Jupyter Notebook, but this is a very interactive, very simple, easy to use notebook meant for Julia. This is the official website of Pluto, plutojl.org. And I am very familiar with Pluto Notebook because a couple of years ago, when we were initially building certain interactive modules for some of the schools that we were partnering with, we initially started to build that in Pluto Notebook. We figured out a lot of things. At that time, it was less developed compared to what it is today. But still, we figured out a lot of technical things which only very few people knew at that time. So Pluto Notebook is something that is extremely easy if you want to build basic interactive widgets or interactive elements to teach or for your own sake of visualization. And in this website, you can see bunch of sample Pluto notebooks. So if you go to their featured section, featured notebook, you will see a lot of very interesting featured Pluto notebooks, which will show you certain interactive elements. But I'm not going to go through all of these notebooks. Rather, I will show you some of the interesting things about Pluto notebooks, starting from how to even install Pluto notebook on your system, how to open it, and how to run your first line of code. So to install Pluto notebook, you have to add its package in Julia. So first go to terminal, as you always do. And here my terminal is already running the Julia REPL. So let me terminate and start from scratch so that you can follow with me. So this is my terminal. And I have already installed Julia, which we have done in the last lectures. So we can simply type Julia to run the Julia REPL. And then we are going to add the Pluto package. So type using pkg, p capital, and then pkg.add Pluto in double quotes and Pluto p is in capital. I have already added the Pluto notebook into my system, so this will not run anything specific to me because I'm sure it will show, no changes because I already have these packages. But in your case, if you do not have these packages, meaning if you have not installed Pluto before, of course it is going to install it. It should not take you more than few seconds. Now, the next thing you have to do is to run the Pluto notebook. So previously what we were doing was we were basically exiting Julia like this, back to terminal, and then we were opening Jupyter Notebook by typing Jupyter Notebook. This is what we were doing. But we are not running Jupyter Notebook at the moment. Instead, we are running Pluto Notebook. So this is not how you run Pluto Notebook, unlike you run Jupyter Notebook. So let me close this once again, terminate the session, restart it, start Julia, and then now I'll show you the command to run the Pluto Notebook. You can simply type pluto.run to run the Pluto Notebook. I forgot to add using pluto.run. So now this should open the Pluto notebook. It should not take you more than 2 to 3 seconds. And you will see that a lot of things about Pluto notebook is very similar in structure to Jupyter notebook, but I want to focus on a couple of things primarily. So this is loading. So when Pluto notebooks loads, it's on your local host, just like how you run Jupyter notebook also on your local host. And here I have already worked on a few notebooks. Otherwise, if you are working on Pluto notebook for the first time, this will be completely empty. And if you want to run some Pluto notebook from this featured, for example, let's say there is a machine learning notebook here, classification of iris. Iris is like a flower, and you can classify the flower based on its petal and sepal length and width. So we'll be running this Pluto notebook also today, although we won't be writing this particular Pluto notebook from scratch. But let's say you want to run this. All you need to do is like find the Pluto notebook from wherever it is and then click edit or run this notebook, it will give you the URL in this particular case. And here, go to your Pluto localhost and you can enter the path here, copy paste this and open. But I'm not going to do this right now. I'll do it, of course, towards the end of the lecture. But right now, I'm going to create a new notebook, which will open an empty notebook. So this is loading an empty notebook, and you will see that Pluto Notebook also has a couple of things. One is a place where you can run the code, like here. So let's say a equal to 5. You can run this code. So for running the code, the keyboard shortcut that I'm using on Mac is Shift plus return, meaning Shift plus enter. But you can also run the same. I'm sure you can run the same by simply clicking on this run button. Yeah, this one. But you can figure out the keyboard shortcut for this on Windows or Mac or whatever operating system you are using, or whatever computer you are using. So this is simply displaying a variable. You can do whatever you have been learning in Julia so far. You can define an array 1 equal to 1, 2, 3, 4, 5, because ultimately the programming language is Julia only. So if you run this, it will display whatever Julia will display. And if you want to display type of array 1, this should display array of int64. But here you will see an error message. And the reason for that is, unlike in Julia, here the code is written in blocks. And usually, if there are multiple expressions in a single cell, so here both of these expressions have been written in the same cell. So this is one cell, this is another cell, this is another cell. Typically, Pluto Notebook only allows one expression per cell. So there are two options here. One, if you click this line, split this into two cells, the two lines, array 1 equal to this and type of, will be split into two lines. Otherwise, let me go back, Control Z. If you don't want this, you can run this, but wrap the code in begin and end block. So basically have a begin block and end block. This also works. So these are the two ways in which you can deal with multiple lines of code. Either put individual lines in separate code cells. Otherwise, put it in a begin and end block. Some basics of the Pluto Notebook. Okay. Now I want to show you some very interesting thing about Pluto Notebook. So let's say I have a variable a equal to 5. Now, one interesting thing is that if you change, you can basically influence the value of a throughout the notebook by just changing it at one location. I'll show you what I mean by that. So let's say F equal to ma is the formula for force, right? So let's say mass equal to 5. Then acceleration a, this I'll just write as m for simplicity, a equal to 10. And we know that F equal to ma, right? M into a. Now, if I run this, is 10, F equal to ma is 50. Now, if I change this to 15, and if I run this automatically, this part is also compiled, because the notebook automatically recognizes that this variable m is also being used in this line, and it will compile this line also. So you don't have to deal with changing things. I mean, running all the cells again and again, the changes will be reflected in all the cells. But one more interesting thing about the interactivity of Pluto Notebook that I'm sure you will like, I just want to show. It's called sliders. So here, instead of defining mass like this, I can write something like this. So let's say at bind mass slider, and range of values are from, let's say, 1 to 100. 1 is to 1 is to 100 means it goes from 1 to 100 in steps of 1. Then show value equal to true, and default equal to, let's say, 10. So this should, I hope if there is no error, this should open a binder, slider, actually not binder, slider, because import is missing. So I think here, to have the slider, I think we have to import Pluto UI, right? Using Pluto UI, I guess. Let's see. Yeah, so we need to install this Pluto UI, and actually this Pluto UI should take some time because it installs several different packages. I had already installed this before, so this time it should not take me so much time. But when you are running this for the very first time, it might take some time because it has several packages to install, but it's only a one-time effort because these packages will be installed on your computer as well. So Pluto UI has been imported, but then after that you can see that a slider has appeared. Now, what I need to do is I need to define that the variable m is equal to this variable mass. So this variable mass defines whatever value is carried by the slider. And I want to assign the value of the slider to this variable m. So here I can define it like that. And then now if I change this, right? Oh, let me run this once. If I change the slider, you can see that whatever is the slider value is taken by m, and that is also reflected in f equal to ma. So this is a interactive slider which can influence the value of a certain variable throughout the notebook. So this is very cool. We can also do something like this for plots actually. So for plots, let's define like a sinusoidal plot, which will be interesting. So x equal to, let's say it ranges from 0 to 5, 0 to 10. So 0 to, in 0.1 steps, it goes to 10. And then y equal to sine of x value for x value in x. So here we are defining, because x is like an array, there are a bunch of numbers. We write it like this. So now we have x and y. Now, one more thing we can do is define a slider to take the value of maybe we need to define a frequency, right? So let's say a is the amplitude and f is the frequency. A sine omega t, something like that. Here x can be replaced by time t. So this looks like a sine omega t, and this I can call frequency. I can call it as omega. Actually, let me keep it as frequency only. Or rather, omega would be better. Now, let me do one more thing. I'll define a slider at bind frequency. This is the new variable name for frequency, which will take the value of whatever the slider value is. Then I'm defining the slider of, let's say it goes from 1 in steps of 1 all the way till 1000, and show value equal to true, default equal to 1. So this should create a slider. Okay, so again, this error is there because I have written 2 lines of code in one cell. So let me split this into 2 cells. It should be okay. But now omega is not defined. Also here x value is not defined. So omega multiplied by t value. So the value of time for t value in t, because the variable that carries the array of numbers is t. One more thing is omega has to be defined. Omega I have not defined yet. So let me write omega as omega equal to frequency. So now what else is missing? A sine omega t, expected closing bracket. Okay, comma should be there, I guess. Okay, so this is fine. Now A is not defined. Yeah, A is also not defined. So for A also, let us define another slider. So this is amplitude. So amplitude, let it go from 1 to 20 maybe. And we can also define a variable called, we already know A, but we want to assign the value of amp to A. And then when I run this error will come. So I'm going to split it. Okay, so now there is no error, but we are not plotting yet. So let's also plot this in a nice looking graph. And what I want to show you is that this will be a dynamic graph, because if I change the frequency, see, you can see that the value of y is changing dynamically, because y equal to a sine omega t. So here, when I'm changing the frequency, omega will change. I mean, when I change Yeah, when I say change frequency, omega will change. So here I'm defining omega equal to frequency, which is not technically correct, I know, of course, but it's okay for the time being. But you can see that the value here is changing. Same for amplitude. When we change the amplitude, you can see that the scaling factor, whatever is this, is getting multiplied. So if amplitude is 1, this will be 0.85. If amplitude is 10, this will become 8.5. Let's see. If amplitude is 10, the first value should become 8.5. You see? So this is working perfectly. Now let's plot this to see the dynamic graphs that Pluto Notebooks allow. So there is a package for running, for creating plots on Pluto Notebook. But before that, maybe we can just try running without any of that. So it should be plot. We are plotting t against y. So t comma y. So let's see what happens when we just run this piece of code. Then it will say plot is not defined. So we can import plots. I'm not sure if it is capital P. Yeah. So here there is a button called notify when done. You can click that also. I hope plots is the right package. In Julia, plots.jl, right? Yeah. Okay, so plots also is installed. So now what is this showing? Okay, now this is showing the actual plot. Now what we can do is this slider, we can change the value on this slider. So this is frequency slider. And what we can do is the time, we can make it a bit more coarse. So instead of 0, 0.110, this, let's make this 0.01 so that it does not look like these sharp, bumpy things. So, but you see here frequency, and I don't want to change frequency to 1000, maybe all the way till 100 is fine. So see, as I am changing the frequency, the sinusoid is becoming more frequent. The length of the wave is decreasing. And this is so cool. It's like dynamic graphs. You can change the value of a parameter and the graph itself changes. I really absolutely love this feature. There is one more thing. So here, by the way, if you change the amplitude, you can see the same thing. So let's change the amplitude. Then you will see that the y-axis value is changing here. So instead of graphing, of course, graph cannot increase beyond the size of the screen. So instead, y-axis gets readjusted, the scale of the y-axis. You can see that depending on the amplitude that we set here in this slider, the y-axis value is changing. So these are dynamic graphs, another cool, very interesting feature of Pluto Notebooks. So I really like this because we can also host the Pluto Notebook separately as a website. But if there are sliders and if the slider has to work, it should be the Pluto itself should be hosted as a separate server. But otherwise, here there is option to download this Pluto Notebook as a static HTML. So if you click this and download it as a static HTML, we can basically host this anywhere. But the problem is this slider will not be active here, although it's moving and you see like this value is changing. For example, here, so this is now an HTML file opened from my local computer. But here, if I change the frequency here, you don't see the plot changing. And that's because this is like a static HTML file, and the value of this variable cannot change based on the value of the slider. For that, we have to host the notebook separately. But that is okay. We don't want to cover that in today's lecture. This is more about all these interactive, nice features on Pluto Notebook. So you looked at the slide, you saw the slider, you saw how the variable values change in all the cells without having to run all the cells separately. You saw about dynamic graphs. So this is nice. Let's just probably do one more thing in Pluto Notebook before jumping into the featured notebook of classification of iris using machine learning. Now, I want to show you two more things. One is an interactive graph, a simple machine learning linear regression. That is the first thing. Second is an interactive data frames. So you might be familiar with data frames, especially the pandas data frame, if you have run codes in Python. But here, let's first do the plotting of the linear regression, that too in an interactive manner, and let's see how it looks like. So here, I don't have to import Pluto UI because it's already there. I have already imported it in the first line here, Pluto UI. But you need something called data frames, GLM, and stats plots. I don't think we are using this at the moment. Let me delete this for now. So now what we need is this. These are multiple lines of code, and it cannot stay within one cell unless wrapped in a begin and end block. So I will take this bind, which is the slider, out of this cell block, the block of cell, and let me put it here. And this I will wrap in a begin and end. Okay, so here we are defining a data frame where x ranges from 1 to 10 and y takes 10 values, 10 unique values, 2.53, etc., etc. And then I can delete the slider. It's because I'm already putting it outside. And if I run this code, this should also throw an error because I have two codes in one cell. So let me add it in a different line. Okay, Okay, so now what we have is we have two sliders. One slider is corresponding to the slope, another slider is corresponding to the intercept. So slope is the slope of this line, and intercept is the y-intercept of this line. And we have defined the equation of the line here, mx plus c. C is the intercept. I mean, intercept is c, and m is the slope. And what we are plotting here is y versus x for these data points. So if I change this 2.5 into 5, you will see this this blue point jumping. So see, the blue point jumped up. Okay, so now here in a machine learning linear regression, what the ML model basically does is we can move this slider up so that you can see. So this is slope, and I can delete the cell. One more thing is you can actually hide the code. So if you click this I button, you can hide the code. So if the entire notebook looks ugly because there are so many lines of code, simply hide all the code so that you display only the output. So this is something that I like, especially when sharing the notebook with someone. And if I don't want to give them the provision to play with the notebook, I just want them to see the output. So in this linear regression, if we keep changing the slope, you can see that dynamically the graph is adjusting. And you see the y-axis values are also adjusting appropriately. So here, if the slope was 50, the y-axis value will become insanely high. See this, it's very, very high. So this is an absolutely beautiful feature, which will be useful in machine learning also, because in the downstream of the course, we will be learning about linear regression. We'll be learning about non-linear regression. We'll learn about traditional machine learning models, deep learning models, etc. So this is one example that I wanted to show where Pluto Notebook is used for simple linear regression. Currently here, we did not implement the linear regression, of course, but we are just showing if a machine learning model is doing it, this is how it will do it. It can play with the slope and intercept, and then it can minimize the loss, which is the fit between the line and the points. But this is not even a machine learning model. It's a fancy name for a simple linear regression. Now here, what I'm going to show before jumping into the iris flower image classification is showing you a data frame. So here, Pluto UI and data frames are not needed. I have already taken it over here. I have already imported it in the previous line of code. So here, let me put the slider out. So first slider in one line, second slider in the next line, and we'll have to wrap this in a begin and end block. Okay, so wrapping is done. Multiple definitions for df. So maybe I can call this as df1, because we used df already in the previous plot, in the linear regression plot. And hopefully there is nothing to take too much time. Okay, awesome. So here, what you can see is there is a data frame, and we are filtering something from this data frame. So in the data frame, we have three people: Alice, Bob, and Charlie. And these three people have some age: 25, 30, 35. They have a score. Score is 88, 92, 85. Now, what we are filtering, so this could be a very big data set, right? There could be more names and more people. So this is only three people. From this, we are filtering people, and the filtering criteria is such that age should be greater than certain minimum age, and score should be less than or equal to, or let's say age should be less than or equal to a maximum age. I'll make it easier like that. So this is maximum age, and score should be greater than or equal to minimum score. Minimum score. Okay. So now what we are filtering is we are taking only people below a certain age. And among that, we are only, because here there's an and condition. So row dot age, basically age should be less than or equal to max age, and score should be greater than or equal to minimum score. And here the data frame consists of names, three names, three ages, and three scores. And here we are defining the filter such that the row in the data frame, each individual row is first passed on to this, and the row is filtered only if this criterion is met from the data frame, df1. So df1 is the data frame. So now what you can see is if I change the slider, this will adjust the value of the maximum age. So now maximum age is getting adjusted. No one is getting filtered because the maximum age I have defined to be 30. Yeah, so now people are getting shortlisted. So basically the score people have had here is 88, 92, and 95, which means if the filter is set at 100 and age is set at 40, there is no one with a score of 100, minimum 100 score, and 40. How about age less than 40? How about minimum score 0 or 80 rather? What if this is 0? Minimum score 0 and maximum age is 40. Everyone satisfies this criteria because everyone has minimum score greater than 0 and age less than 40. So everyone satisfies this criteria. So everyone is filtered out. But if we say age should be max 29 and score should be, so then Alice is there, but then Alice will be out if we set the score to be 90. So let's move with this to 90, 92. No one is there. So below the age 29, only Alice is there, but Alice does not have a score greater than 92, greater than or equal to 92. So here, this is how you can create custom filters. So if you have more criteria for filtering, you can add that also, and you can adjust the sliders, and you can filter out a set of people from this data frame. So this is another example using which we can manipulate data frames and display it in a very nice dynamic manner. This is again using Pluto Notebooks. So I want to wrap up the Pluto Notebook introduction here, and now I want to jump into the Iris dataset classification, which is this one. I'll show you from scratch how exactly to do this and use this and what exactly to do. But before that, I also want to tell that in this course, we have not even started machine learning yet. And I don't want you to feel intimidated that we are suddenly jumping into a data set that does a classification task. So don't worry about that. We'll not be focusing a lot on all of these things. Rather, we'll be focusing on the functions and features in the notebook. We can run the notebook just like how you run a Kaggle notebook or how you run a Jupyter or Google Colab notebook. We can run the same thing here in Pluto Notebook as well, so that you know what is ahead of the course. So I just want you to get a flavor of how implementing machine learning models in Julia can look like. This is one of the ways in which you can implement, right? So let's get into that. So now this is how you access the featured notebook. You go to plutojl.org, click on featured notebooks, and there are so many amazing notebooks. You can open any one of them and play with it. You will learn about Pluto a lot. But today I'm going to show you this machine learning notebook on classifying iris. So click to open this, but we have to edit or run, right? So click edit or run. and copy the URL over here. So copy this, close this, close this, and go to Pluto. So in Pluto, we have all these codes that we have been running. So to get back to its landing page, kind of the first page that we saw, click on the pluto.jl logo. Then we will come to here and scroll down, find this open a notebook thing, and then paste the URL here and click open. So this should open the iris classification Pluto notebook. So this is where we'll be working. I'll close the rest of the things. So now we will work on classifying iris. So let's first look at what exactly this notebook is about, right? So this iris is like a type of flower, and there are, I think, 3 different varieties of iris: setosa, one more, and one more. I forgot the name. This is like a famous data set. So if you go to Kaggle iris data set, Kaggle, uh, uh, you know what the verb, I think one is called for sure it's called setosa, the other is called I have no idea what the name is. Species, iris species data set. Yeah, I just need to go to Google Images so then we can see the plots. Yeah, Setosa, versicolor, and virginica. So these are the 3 species. So here also we'll be doing the same thing. So first here we can click run the code, run the notebook code. Then it will restart the notebook. And running, I don't know how much time it will take. It will definitely depend on the number of packages that you have to install. Here you can see that there are 163 things that are being installed. Last time when I ran this, I think it took some time. So, but since many of the packages in this notebook will already be installed on my computer, this probably won't take much time for me. But if you are running it for the first time, perhaps maybe running this notebook might take some time. But anyways, so here in this notebook, we'll be implementing an ML algorithm for classifying these flowers. So the iris looks like this. So it has 2 things, sepal and petal. So to see what exactly that means, you can open this image. So one of them is petal, one of them is sepal, and it has a width and length. Let me open a better image perhaps. Yeah, so this is sepal, this big one. Petal is this small one. So it has a length and a width. Petal also has a length and a width. Now we can see how by calculating, by knowing the sepal length, sepal width, petal length, and petal width, how can we classify iris data. So here we are not going to use image data, rather we are using tabular data, because we have a table of data set which includes the length and width of both of these. So we'll be using an algorithm called KNN. KNN is called K nearest neighbors. This also we'll be covering in detail in the course, but I just want to give you a glimpse of what exactly this notebook is doing. So don't worry if you are not understanding the machine learning terminologies or the specific technical terminologies here. So here you can see that data frames, plots, Pluto UI, and there is one more called random that is being used. These 3 you saw previously in the previous notebook itself. Now in the data preparation, here we are importing the data set. I don't want to run the notebook right now. I'll just walk you through the notebook for you to see what all things Pluto Notebook is capable of doing, right? So here you import the data set, and there is sepal length, sepal width, petal length, and petal width. And then based on that, there is a classification, Setosa, Virginica, or the third one, I think it's called versicolor, right? Yeah, Setosa, versicolor, and Virginica. Now, we split the entire data set into training and test data. So I think what we are doing here is we are repeat to get 150 items, assignment, chunk, train set test. So basically 4 out of 5 is training and 1 out of 5 is testing. So it's like a 80-20 split. And here basically we are randomly picking data set into either training or testing. And then after splitting, we have this as the training data. It has 120 items. In the original data, how many items we had? The length of this column was 150, right? So out of 150, 30 is used for testing, and which is the 20% of 150, and remaining 120 is used for training. So now in this training data, there are test data, there are 30 rows. Training data, you have 120 rows. So now here we can select features. So here what we are doing is plotting the data set according to sepal width and sepal length. And you can see that here there are clearly like three clusters forming. Forget about this white dots, but if you look at just the data set that has labels, I think the white dots might be the test data, perhaps. I'm not sure. But here you can see that the yellow color, which is setosa, has, I would say, highest sepal width on an average compared to all the other flowers in it, but it has less sepal length. Blue and green has significant overlap, so I'm not sure how well we can classify this. But when we run the model, we can actually do this classification. So let's actually go step by step, classify random, this random package. Yeah, so we have to fill the random function with this missing line of code. So here the random function is missing. Let's code this part. So we can replace this with species. And now when we run this, hopefully, yeah. So basically we randomly selected a species. Here you can see this hint box. So hint box is something like if you hover your mouse on top of that, it becomes readable. You see this? On mobile phone, this will appear as if you have to tap, because on mobile phone, there is no mouse pointer. So these are some amazing features that you should definitely explore, which Pluto Notebooks have. So here there is something else called start by comparing. So basically we should be comparing prediction with the pair with the actual answer. So let's do that also. So we are looking at whenever answer is not equal to prediction, we are calculating the percentage of such, answer equal to prediction, we are calculating that. Try to run. This error is probably because of missing import, because I'm not sure if this mean is defined. So we might have to import a package. So using statistics. Okay. This should take a couple of seconds to finish running. And once we have the statistics package, I hope the mean should not throw any error. Okay, so that ran. So it was the error was because this mean was not defined. We needed the statistics package. We had to manually calculate the mean otherwise. Then classify random. I don't want to go into all of this. I just want to show you the baseline classifier with training data. So basically, here for each unit sepal length and sepal width, you are defining whether it is supposed to be setosa or virginica or versicolor. And the initial classifier that they use is a random classifier, and it makes each cell's color into a random color. And so the prediction will be random. So you can see that while the dot is yellow, the shape of the color of the cell is blue. Or here, for example, the dot is green, but the color of the cell is green. The dot is blue, color of the cell is green. But and for test data, it will be again very bad. But however, we can check at the end how well the classifier works at the end, because this is a huge notebook. If I run this whole thing and explain it today, the video length will be much longer than what I intend to make it. But I just want to show you the visualization of results from the k nearest neighbor. So yeah, so this is the k nearest neighbor classification visualization. So basically it takes any given sepal length, sepal width, petal length and petal width from the flowers as the data. And based on that, it will predict whether the given flower is a setosa, virginica or versicolor. And you can make these amazing plots. So what you are seeing here is that whatever code you can run in Python for classification, you can pretty much run the same thing in Julia also. For many tasks, Julia is much faster. And Pluto Notebooks give a really good way for you to visualize all of this. I think we can run most of these things in Jupyter Notebook also, except probably for these sliders and interactive widgets. But other than that, I'm sure like all the other things, all like 90% of the other things that are used here, we can run normally using Jupyter Notebook. So for the rest of the course, I will not be coming back to Pluto Notebook very frequently unless we're absolutely needed. I'll be sticking to Jupyter Notebook only. So we'll be running Julia in Jupyter Notebook. Sometimes we may try to switch to Visual Studio Code also if someone is interested, but for most part of the course, we will definitely stick to the Jupyter Notebook. So this lecture was primarily an introduction to Pluto Notebooks, and I really wanted you to know about the fact that something called Pluto Notebook exists. I did not want you to miss this. So, but even if you never plan to use this, just know that Pluto Notebook has some powerful capabilities compared to what just the Julia REPL, like in the terminal or Jupyter Notebook, what that can do. Pluto Notebook can do something much more better than that. So this brings us to an end of this lecture. We will start now implementing data science techniques in Julia starting from the next lecture. So the next module will be covering data science. The module after that will be covering machine learning, and the module after that will be covering some deep learning. So now it's a good time for us to officially start working on machine learning. And machine learning, when I say machine learning, I broadly mean all the things coming under that umbrella. And I also want to take a moment to congratulate you since you have already reached at this part of the course. This is a good stage to be in. You have now a basic grasp of the Julia language, although you may not be an expert. It's okay because you will learn the functions, implementation, coding, all the errors, figuring out how to fix it. All of this you will learn throughout the course. So you should really feel good about the fact that you have reached this part of the course. So once again, thank you so much. Please take care until the next lecture. See you in the next one. Bye.